Okay, chapter 6.4, we're going to talk about elimination method, not just by adding or subtracting, because you guys will have to do that here as well, but we're going to use multiplication. I outlined a couple steps here. Hey, these are the exact same steps as you guys had last time, but I inserted one more step from last time. So it's not like you have to copy all of these down. You just need to kind of insert this into those last steps we had. And that one was, or is, multiply one or both equations by a constant to get the two equations to contain opposite terms. Now, we want to say opposite terms because I want to be able to add them together. I want to add because when we subtract, we have to worry about the negative signs, and then we get them all mixed up. And so, we want to multiply to get the x's to have the same coefficient, but opposite in sign. So 2x and a negative 2x, 8y, a negative 8y. So when you add them together, boom, they're gone. We engineer it that way. Notice it still put the systems in the standard form. Get the x's over the x's, the y's over the y's, the constants over the constants. Multiply those equations, and then add. I took out the subtract on that as well. So you're just adding to eliminate or cancel one of the variables. So you can solve for it in step 4, and then you can use that known variable to go back to the original problems like you did last time to solve for the remaining one. And of course, you should always check your solution at the end. So for the first example, we're going to demonstrate just multiplying one equation. If you notice that I already have this in standard form, 90% of your problems are going to be that way. So just be mindful that the x's and y's very well could be switched on you. So you have to take care of that. And that could be part of the problem we had in the quiz last time. Is we have 6x minus 2y equals 10 and 3x minus 7y equals negative 19. What I tried to do is look for the easiest ones that I can say, if I just multiply this number by some constant, I can make it look like the other number. So can I make a 6 look like a 3? Yes, I can. I could divide it by 2 or multiply it by half, but then that's multiplying by a fraction. Nobody wants to do that. So we're going to not use the 6. What about negative 2? Can I make a negative 2 a 7 really easily by multiplying? It'd have to be multiplied by 3.5, right? Nobody wants to do that. 10 and 19, don't worry about because we're not trying to get rid of them. So we jump down below. Looks like at negative 7. Can I make a negative 7 a negative 2 by multiplying really easily? No. But can I make a 3 equal a 6 easily using multiplication? Yeah, multiply it by 2. So if I multiply 3 by 2, I can get 6x. Or 3x times 2 is 6x. But remember, I don't want it to be the exact same. I want it to be the exact opposite. So in this case, yes, I'm going to multiply that second equation by 2, but I'm not going to just multiply by 2. I'm going to multiply it by a negative 2. And so how I show that is I use parentheses around the whole entire equation, and I put a negative 2 in front. This negative 2 needs to be distributed through. You need to distribute the negative 2 all the way through to that second equation. So let's do it. Negative 2 times 3x is negative 6x. A negative times negative is, and a 2 times 7 is, so it's a positive 14y. Everybody with me? And negative 2 times negative 19, again, will be positive, and it will be a what? 38. Is everybody able to get that by multiplying the second equation by negative 2? Then what I'm going to do is I'm going to add that back to that first equation. let's make it easier for ourselves. Let's just take it along for the ride and place it underneath. So all I'm doing is rewriting that equation underneath so I can add them together. And now this problem looks just like last section, which was just add them together. And if you add them together, what happens with the negative 6x and the 6x? They cancel. We engineered that to happen. If you add your two equations together and something doesn't cancel, you made a mistake somewhere. So those two will cancel each other out. You just need to remember to add all of them. So what's 14y plus a negative 2y? Or what's 14 minus 2? It's 12y. And 38 plus 10? 48. And to solve for y, all I need to do then is divide both sides by 12. If you divide by 4, you'd have to keep dividing it more. And so we get y equals 48 divided by 12 is 4. Okay, we're not done. You only solved half of it. Now again, this is just like when we did the last section by adding or subtracting. You need to place it back into the original problem, and you need to, or one of the originals, doesn't matter which one, and figure it out. The other variable, in this case x. Which one looks easiest? Top one, maybe because there's more positive numbers in it. There is no rhyme or reason necessarily sometimes for which one you're going to use. But 6x minus 2 times 4, notice that when I'm subbing back in y, I use parentheses, equals 10. 6x doesn't change, minus 8 equals 10. Ethan's on a timeout. What's my next move? Add 8 to both sides, not just to the 10. So those cancel out. So 6x equals 18. Final step is divide by 6 to both sides. And so x is equal to 3. We now found x and we found y. We should do what though with it? Write it as a point. Right. Write it as a point, x comma y. So your values, or your point is, point of intersection between these lines is 3 comma 4. Then, obviously, on the last slide, the very, very last step should be take the x's and y's and plug them back into the equations to make sure you're right. And I'll let you guys do that on your own. Next one. Step it up a little bit. On these particular problems, we need to multiply not just one, but we have to multiply both equations by something to make it work. And this, guys, is where we're going to have to use kind of the idea of the least common multiple. What is the least common multiple of the x's or the y's coefficients? So these ones are not going to be easy. 2 does not go make a 5 real easy, or a 3 make a 5. So you're going to have to multiply each equation by something else to make it so that they do come out to the same number. So you can choose if I'm going to work with the x's or with the y's. In this case, I'm going to work with the y's. Does anybody have a good idea why I chose the y's over the x's? Dave?
Actually, no. Oh, because they're both, if you divide, they're both 2. If you divide, the equals is 2 times that number.
No.
But negative.
Okay, I'm not sure if
Minus 2 times that number. Because 3 times.
3 times 2, though, is going to be 6 and not the 5 for the y's.
But it would be negative 2.
Okay, we're going to move on and see if it's a little better.
One's negative and one's positive.
One's already positive and one's negative. So that way I don't have to multiply anything by a negative number. And anytime I can avoid using a negative in my directions, the least likely I'm going to make a mistake. So that's why I'm going to get rid of the y's this time. Now, you got to look at a 3 and a 5. I'm ignoring the negative right now, but 3 and 5 both go into what number?
15.
15. So, that's my goal. The top one will obviously be a negative 15. The bottom one will become a positive 15. But 3 times what is 15?
5.
So I'm going to multiply the top equation by 5. And I'll multiply the bottom equation by what?
3.
3. Because 3 times 5 is 15. Okay? So let's go back to the red one there, the top one, and start to distribute it in. 5 times 5 is 25x. 5 times negative 3? Negative 15. We engineered that one to happen, right? And don't forget to go all the way across. 5 times 6 is 30. Is everybody okay with that? Distributing. Changing up to the second equation. 3 times 2x is 6x. 3 times 5 is a positive 15y. We should have that happen. And 3 times negative 10 is negative 30. Is everybody okay with that?
I am.
At this point, do you guys see that the y's have the same coefficient but opposite in sign? We engineered that to happen because what we want to do here now is add them together. And if I add positives and negatives of things, they will disappear or go to 0. We don't have to write them anymore. What's 25 plus 6?
25 times 6.
25 plus 6.
Oh, 31.
31x. And wait a minute. 30 plus a negative 30. 0. So 31x times 0. Anything times this number will result in 0. I don't know. Well, then we'll just divide both sides by 31. Anything divided, 0 divided by anything is 0. There's nothing, and you want to divide that nothing to 31 people, everyone is going to get nothing. So we found x. Now we just have to find y by plugging it into one of the equations. Which one looks the easiest to you? Bottom one? Okay. 2 times 0, notice I'm using parentheses, plus 5 times y equals negative 10. 2 times 0 is just gone. So that leaves me with 5y equals negative 10. All I have to do now is divide by 5. So y equals negative 10 divided by 5. Negative 2. And to finish the problem off properly, we will write it as
0, and then negative 2.
0, negative 2.